and I work at this nice place in Potsdam. And in our institute, we have, besides our main scientific departments, cosmic magnetic fields and X-ray galactic astrophysics, a focus point on development of research technology and infrastructure. And part of this is our eScience group, where I happen to work. What we do is we mainly do data management for our scientific groups, and we also work on publishing this data for a brighter astronomical and for a brighter astronomical audience. So, and basically working on this, we gained considerably experience in this whole business of virtual research environment from various projects in the last, let's say, 10 years. So, okay, what are virtual research environments? The term itself, I think it's around for 10 years, first from the UK, and it's kind of a hard thing to track down because there are also several alternative names for the same thing. And basically, different people usually think of something different when they hear this, this term. So I would try to circle around a bit what this virtual research environment means. So in general, you have a cooperative research platform, and this cooperation or this collaboration should be available from different institutes in different countries or even continents. So the virtual research environment potentially comprises the whole research process, from getting the data, working on the data, post-processing, and writing papers, doing publications, but only potentially. I will come to that in a few minutes. It's based on software services and communication networks, web interfaces, APIs, login over the internet, these kind of things. And it mainly provides access for scientists to research data, to different tools to work on this research data, to resources, and sometimes also to real-world, let's say, real-world infrastructures like robotic telescopes or other facilities. Another important thing is that these virtual research environments form somehow virtual organizations. So, like think of it as collaborations beyond the usual administrative structures of universities, institutes. Okay, I put here some references. You can, if you want to look it up, you can do it later. Basically, there are a lot of studies, like let's say some meta studies on what these structures are. Okay, how are virtual research environments connected to open science? For this a diagram which goes back to Treloar et al. And was significantly improved by Jens and myself and other people in the Radieschen project, is quite helpful. So if you see this, or if you look onto research data in this in these four different domains, so the private domain is basically the private workstation of the researcher. The group domain is when the researchers form collaborations and work together on infrastructures on the same set of data, but still in a relatively small group, confined group. Then we have the domain of preservation, where archives are living basically, and later open science lives in this domain of access and reuse, when you make this data available to a broader audience. And why virtual research environments live in this group domain. And the effort of data management and the complexity of metadata and basically the work you need to put into the data to make it usable is increasing from left to right. So when you have proper structures in this group domain, you can basically save work you need to later to make this data available for a broader audience doing open science. So because this term is kind of not really, this term of virtual research environment is not, it's hard to track down, and made this little sketch to visualize it a bit. So what a virtual research environment basically is you have like different institutions, universities all over the world with users who are using different facilities like perhaps databases or supercomputers, or even some facilities, research facilities like a telescope on Canary Island, or something doing with stones in Siberia, and getting PhD degrees and doing nice science. So that's the main idea, and that's the ideal world of virtual research environment magic. So obviously in reality it's not that easy, and during the last years a lot of issues appeared with these structures. So most of these research environments do not evolve beyond a prototype setting. That has many reasons. Some of them are that people underestimate the amount of effort they need to spend to form this organizational structure, because usually people want to solve a technological problem or basically a problem in their research workflow. Also, to long-term fund these kind of structures, it's hard to achieve because you don't have one. In general, you don't have one institute basically spending the money for this environment, and also different stakeholders like supercomputing centers and institutes and universities and researchers have different agendas regarding this whole topic. And another problem is that virtual research environments are not yet that accepted in their particular community, because scientists, as you probably know, cling to their established workflows. They don't like changing their tools and their environments. Another problem, coming back to my first slide, was that the coverage of the whole scientific workflows might conflict with other tools people already use. So if you have everything from research data to writing papers in one new tool, that might conflict with things that people used before and liked. And also, sometimes if the creation of this virtual research environment is too much technology-driven, the integration and the basic advertisement in the particular research community is not sufficient. Okay, so I will now go to give you a few examples of virtual research environments in different fields. First, I forgot this one. If you want to learn more about these different issues with virtual research environments, I was involved in a project on defining success criteria for the development and sustainable operation of these virtual research environments, together with people from Göttingen and from Dortmund, basically evolving from this experience in different projects. So the project results are available unfortunately only in German right now, but we are about to publish them in English as well. You can go to this webpage to find further links to the publications. We worked on, for example, some kind of life cycle for virtual research environments, and also on different aspects of these different criteria for the success. Okay, so first example is the text grid virtual research environment. This is kind of some people say it's the only classical virtual research environment that seem to work in Germany. They evolved beyond this prototype and now working on a plan for having a sustainable operation of this thing. It's supposed to support scholarly work in the humanities, so it's about doing annotation on text corpora and collaborating on these things. This virtual research environment basically has two components. The one thing is called Text Grid Laboratory, and it's basically modified Eclipse IDE, where the people can to use different tools and XML editors, basically adapted to their workflow from the humanities to perform these annotations on the texts. And they have a text script repository, which is basically an archive for the research data they produce in these workflows. Okay, coming back to open science. So what you get from the open science point of view is you have this text script repository where you have humanity research data, basically text, or in this case, because we're in Vienna, I put the magic flute, Zauberflöte, as a big XML file, or poems, or basically text files, which you can then use to do your humanity studies, or maybe you want to do something else with it. So this is open, obviously, because the work of Mozart is public domain right now. It wouldn't work with current day literature. So, but this is basically a way to get science data into the open as a kind of byproduct of this virtual research environments. Okay, I think I'm running out of time, so I will be very short on this one. So this is a different virtual research environment from the social sciences in Germany. Here the thing is that the data is not really published, it's not even data in this virtual research environment because it cannot share the data over the internet because of privacy laws and privacy issues. But they can share the metadata about their studies and they can share the source code for the analysis of these studies, which they call syntax in their particular in social sciences. Okay. So coming back to the work we do at the AIP, is we have a virtual research environment for the FUSE collaboration, which is a collaboration of about a bit more than 30 scientists from different places in the world, and basically they have computer facilities in our institute to process data from cosmological simulations. So when basically they use supercomputing centers to perform cosmological simulations, which then in the visualization looks like this, and then all these postdocs and PhD students, they need to run scripts and analyze this data to produce things like halo catalogs, which then lead to publications and graduation. And this, basically what they need is very low level. They just need an SSH login and they need some compilers and some scripts, basically a place to run their programs. And of course basically what they need is just an SSH connect into our machines. And of course we have a lot of work keeping all these data, all these storage facilities in order. But now coming back to open science, now we have this cosmological data. And what we do then is, of course in agreement with the scientists, to put these cosmological simulations on the internet again, where they can be accessed by anyone using SQL queries. SQL, because SQL is in astronomy is kind of the standard for these kind of data portals. And what you can do on our page, cosmosim.org, is you can go to this web page and you have a kind of free-form field here where you can put your SQL query, and then you query this database of several terabytes, not petabytes, terabytes, and get the data and can do science with it. The idea behind that is kind of similar what you guys do at Google. We want you to share the query, not the data, so you don't need to send around